outside Tucson. Awesome. Well, thank you everybody for joining. Just such a wonderful spread of people from all across the country. Really happy to have you here today. It looks like we have a lot of people in, so we're going to get started. We have a lot to cover. Before I introduce our speakers, we have a few housekeeping items to share. First, I really want to express gratitude to Sky Island Alliance's donors, volunteers, and everybody else who's turned in to this call this morning. Without you, none of our work here would be possible. We spend our time protecting the water, wildlife, and communities in the Sky Island region, and we certainly couldn't do it without you. So thank you for taking time out of your busy morning today to join us. For those who may need to leave a little bit early today, we will be staying on through 10:30, so that's an hour. But if you need to leave early, this will be recorded and placed on our website later today. If you registered for this via Zoom, I will be sending out an email either this afternoon or tomorrow morning with a link to the recording in case you want to watch it. And then finally, if you're tuning in via Facebook, welcome. We're happy to have you. The recording for this event will also be available on Facebook after 10:30, or you can find it on our website. We'll drop a link to our coffee break page in the chat box for you. If you have questions during this presentation, please type them into the chat box here in Zoom or in the comments if you're watching on Facebook. We'll probably have a little bit of a longer Q&A session today, so please do feel free to ask any questions you might have about monsoon or rain or climate or anything like that. If you used our Zoom registration page to turn in questions early, thank you. I have those and I'll make sure that those are asked. Finally, I want to acknowledge the privilege we have to be here in this region today. The Sky Island Alliance office is based out of Tucson, and all the work we do on both sides of the border, so in the US and in Mexico, throughout the Sky Islands, is on the land of the Tohono O'odham, the Pascua Yaqui, and other indigenous peoples. With that is our housekeeping items for today, so let's jump right into the presentation. I am honored to introduce our friends from CLIMAS, or the Climate Assessment for the Southwest. They'll be sharing their knowledge and research about our monsoons with us today. So we are joined by Mike Crimmins and Ben McMahan. I'll have both of you two introduce yourselves, if you don't mind, share a little bit about your background. And Mike, why don't you start?
Sure, good morning, everybody. It's really great to be here. It's so fun to talk when we're not in the middle of deep drought conditions. It's been raining. And so having this rainfall recently makes these kinds of discussions much more interesting and fun to actually do. So I'm a climatologist at the University of Arizona. I'm from Michigan originally, and I'll be interested to hear if there are any other Michiganders out there. There's a lot of Midwesterners out here in the Southwest, and we tend to kind of drive a lot of these meetings when we get together. Been here for about 20 years, and my undergrad is in atmospheric science and meteorology, and I was on my way to work at the National Weather Service, and then decided I want to keep going back to school. Ended up here at University of Arizona, studied climatology, have been in this position as a extension specialist in climate science since 2005. So I've been here for about 20 years working on climate. So did you want me to do more, Anna, or did you want Ben to introduce himself?
No, that's perfect. Yeah, we'll move on to Ben. I know you have a big presentation, so we'll get to that. But yeah, Ben, what about you?
Hey, yeah, I'm Ben McMahan. I'm a research professor here at the University of Arizona. My background's actually in anthropology, environmental anthropology, but kind of dabbling in or moving into the climate and data spaces. And so here in the Southwest, I work a lot with climate data, climate information, and how we use that information to inform decisions, kind of the way that people can integrate those types of information into projects they might be doing or research they might be doing. A little bit of background, I'm also from the Midwest. I grew up in Nebraska, came to Arizona via Idaho, and a little bit of time in Mexico. Some of my previous work on the environmental anthropology side is kind of weather adjacent. I did a lot of work in the Gulf Coast on the impact of hurricane and disaster, kind of the accumulating impacts of storms and floods. And so when I came to Tucson, thinking about the monsoon was kind of a natural fit. And it's a slightly different mechanism, but it's really thinking about how do we deal with when it rains a lot, like what does that impact as far as, planning and decision making, but also, when it's not too dangerous, it's actually kind of an exciting time of year. And, recognizing that it can be dangerous for some people, but also that it's a time where we really look forward to that break of the heat in June as we transition into this monsoon period. And so, it's kind of an exciting time to be talking about weather and climate. So I'm happy to be here.
Awesome. Well, we're really excited to have you both on today. Thank you so much for joining us. To kick things off, I would love to know your thoughts on last weekend's regional rain events. I know some parts of the Sky Islands got quite a few inches of rain or more, which has been so needed. But what implications do these events have for the region, and what can you tell us about what happened last weekend?
You want me to go first, Ben?
Sure, yeah, go for it.
Yeah, I was actually living it. So Ben's in California right now, and we've been chatting a lot. And I really kind of bummed you didn't able to see it in live person. It was amazing. So the Tucson airport, which is one of our official gauging stations, and again, it's not perfect. It doesn't represent every part of the region, but it's kind of got a long-term record, and it's one of these places that we use as a metric to measure monsoon variability over time. Had crossed into record July wet conditions, and we've got a couple days left, maybe a little bit more on top of that. But that is striking. I mean, it crushed one of the earlier records. Ben and I were chatting as we saw a storm park right over the airport 2 days ago and dump 1.27 inches and just pushed it right above into record July territory. So it was desperately needed. We've been in deep drought conditions, especially short-term drought, given our failed monsoon last year and then dry winter conditions. That's pushed us into, really uncharted territory, at least in the instrumental record of having that deep of drought for about an 18-month period. The vegetation looks stressed. We had issues with fire all over the state. So this has been really, really important. And I should make sure I mention too, it did not solve all of our drought problems. I mean, this has been really, really beneficial. The hope is that we continue to see some precip through the summer. And then as far as eating at our long-term drought, we really need to see some good winter precipitation and then, at least, good monsoon activity next summer. So it's going to be a long-term battle for long-term drought conditions. And we have climate change going on in the background too, which is increasing temperatures, reduce that effective precipitation. So that's going to be a longer-term challenge for us as well.
That's a great overview. I would just say that the thing that's been striking to me, especially living vicariously through data from afar, is just how egalitarian this monsoon has been compared to some. Not everyone's getting as much, but even just those reports that came in as folks were rolling in. Sometimes we see monsoon years where, somebody gets close to average, somebody gets above average, but a whole bunch of places will get hardly anything or not, just kind of on the low end of that spectrum. Not everyone has gotten to their record totals necessarily, but lots of places are running either at or well above average for the sort of seasonal total to date. I'll talk a little bit more about that when we chat in a moment, but it's just been really kind of, as Mike said, a nice break from last year where pretty much region wide we saw below average or even record low totals. This time around, we're seeing, a lot of pretty normal to even above normal monsoon, which has just been, fantastic. So.
Awesome. Thank you both for your commentary on that. I think we all know that getting all of this rain has been so important for the region, especially with droughts and airification and climate change. But I think we also are really curious to know how this is all happening and kind of having an introduction to monsoon. So I know, Mike, you have a presentation for us there. So I'll hand it over to you to kind of talk to us about that.
Okay, let's give it a shot here. And I can't remember, did you want to do questions within, throughout, at the end? Oh no, we're doing the chat, right?
We'll do questions through chat. So if anybody has questions, please drop them into the chat box. If there's a question for clarification, I'll ask that right away, but otherwise we'll save it to the Q&A session at the end.
Okay, that sounds great. Okay, so I'm going to try to do a monsoon primer in about 15 minutes. So this will be really, really high, and I'm not going to kind of go deep into some of the real nuances. And the thing that has always impressed me about the monsoon, and again, knowing my background from Michigan, kind of trained in meteorology and sort of really an Eastern mindset about low pressure systems, fronts. The weather moves from the west to east. The monsoon is still a challenge for me to get my head around and understand how it works. And so it has been a 20-year learning process, and I'm nowhere near to being done. And every summer I go through, I go, oh, that's interesting. I hadn't seen that before. And I learn a new thing. And so that's really been fun. And I hope I get to live here for many more years and continue to learn because it really is such an interesting and unique phenomenon that really is unique to certain parts of the world. And we happen to share in that. So I'm going to do this sort of quick overview. So I'm going to talk real quickly about patterns of climate across Arizona. So just sort of the physical geography of precipitation in particular across Arizona. And then just real quickly touch on the seasonality of precipitation, which is really unique to the Southwest and is a kind of a critical part of the way our ecosystems function and have evolved over time. And then we'll do this sort of evolution of the mechanics of the North American monsoon system. Okay, so just starting off, this is a map, a long-term average map. This is using something we call PRISM gridded climate data. It's taking long-term observations at stations and then using a statistical method to interpolate it against an elevation grid in the background. And this just gives us a sense of how the patterns of precipitation stack up over time. So again, this is average, an annual average. So it wouldn't be any particular year, just averaging over many years. And just what I want to impress you, this is super obvious. Everybody on here knows this, especially being part of Sky Island Alliance, is that we have this really important pattern of it raining more at the top of mountains than in the lower elevations. So we have this real critical determinant. But there's a subtle sort of difference across the state too, is that we have high elevation areas that don't get a lot of precipitation. The Four Corners region, the high Colorado Plateau Desert, which is in this really kind of light rain shadow. And then if you look towards the southeast part of the state where we're here, we actually have more rain in between the mountains than you would at, say, the northwestern part of the state. And that really is the monsoon season bringing more precipitation to the valley locations, having precipitation generated on mountaintops and then moving into valleys. And so just this real subtle difference in total precipitation is evident on our sort of topographically driven climate maps right here. Okay, and then everybody knows this sort of kind of context to set the discussion here is that elevation is important, same map down the lower left here. But then we talk about biomes, and I always like to say that climate is the most important part of determining biomes. Soil scientists would say something different, and any other scientists as well. But you know, this climate element and especially seasonality really shows up across the biomes and the kinds of vegetation and plants and animals we see in these different biomes. And so you can see here amazing ecological diversity across the state due to topoclimate. And then we also have some sort of subtle things, the Mojave Desert in the far northwest corner of the state, the Sonoran Desert in the middle, and the Chihuahuan Desert. That gradient across the state is largely associated with the seasonality of precipitation. So Mojave Desert is largely winter precipitation, so it kind of connects up with California's Mediterranean climate. Chihuahuan Desert is more summer dominated, so it's more monsoon. Sonoran Desert is that kind of mashup of the two and getting winter and summer precipitation. So that kind of hemispheric climate variability converges across Arizona, which I just think is super cool. And as you watch the weather unfold through the year, you'll see this occur when, you know, we'll be hearing about storms in Flagstaff, there's nothing down here, and then it'll be raining in Douglas, and there's nothing else going on in other parts of the state in the summertime. So that to me is really kind of important and cool. Okay, so, and then just to draw out the seasonality aspect a little bit more, so thinking about Arizona as a whole, this seasonal climate is really critical, and that'll kind of set us up to talk about the monsoon. But we have two wet seasons. I always use air quotes because they're not, you know, sometimes they're really wet, oftentimes they're not, but sort of this pulsing of moisture. So wintertime, we see this sort of rise in precipitation. This black line right here is the median precipitation. You'd see the average over the entire state of Arizona. So watching that black line as we go through the seasonal cycle here is it kind of bumps up through the wintertime and then starts to fall between March and April. So we get into our very, very typical dry season, bottoming out in June, typically our driest month. And then there's this real strong rise in precipitation and then peaking typically in August and then falling off quickly in September. So we go through that cycle every year. Winter type storms coming from the mid latitudes in the westerly, so low pressure systems coming in off of California, kind of sometimes they'll drop down here and give us that precipitation. That jet stream recedes north in the spring, and so it's replaced by a high pressure system, so we're under high pressure, so it's clear skies, warm conditions, and then it gets windier towards the end of the spring. And then that is replaced as the high pressure moves north, as then it starts to drag in moisture from the south, which we'll talk about real quickly. Okay, and then finally on the seasonality, I just want to show you this gradient across the state. So these little boxes here represent average climate and what we call climate divisions. They're just zones of counties averaged up together. Each bar is the long-term monthly average precipitation. So the values don't really matter. It's just sort of the comparing to each other. And so kind of draw your attention to Southeast Arizona. You see those two bars right there are the tallest ones are July and August. You can look at July and August in other parts of the state, and they're not quite as tall as the southeast part of the state. And that is really because monsoon central is in Mexico. So the closer you are to Mexico, the more that monsoon precipitation becomes important. And the further north you go, the proportion of seasonal total precipitation that is contributed by the monsoon falls off. And as you go further north, it becomes less and less and less. And you get into California and it's almost non-existent. They do get some precipitation, but it's more, California is a Mediterranean climate, winter is more important there. Okay, so then North American monsoon system, we'll go through this fairly quickly and we can come back, circle back on questions here, is again, lots of minuscule, small moving parts in the everyday, and we can dissect last week's weather event, but largely monsoon season. And so monsoon is from the Arabic word mausim, which means seasonal change in wind. And so it is about some kind of shift in wind direction. And so what we see observationally here and what tracks our monsoon here is a shift in the upper level wind flow. And that's associated with going from the westerlies to southerly, southeasterly flow. And so this is in May, and it's the average, this is 500 millibar geopotential height. So that's just the fancy measurement of the height of the 500 millibar level, which is about 15 to 20,000 feet, depending on the temperature. And that's just going to give us a sense of what the circulation pattern is at that level. So below where planes typically fly, above the mountain ranges just slightly. And so the cool colors are going to be colder temperatures, and the warm colors are warmer temperatures. And so in the northern hemisphere, flow is clockwise around high pressure systems. So in that color, that pretty rainbow color gradient, the wind is coming from the west and blowing towards the east. And where there is a sharp change in the temperature gradient is where the jet stream typically resides. It's responding to that. And so over Arizona and over the southwest in May, the wind is coming out of the west and going towards the east. And that's a dry flow of air because the Pacific Ocean is cool and above it is dry air. And so that flow right there is not going to do much for us as far as generating any kind of precipitation. And May's dry. So as we move into June, we start to see those colors warm up. The sun is getting higher. We're at the longest day of the year on June 21st. Those land masses are now heating up, and they're heating up faster than the ocean. Remember, that's cool ocean water on the Pacific. So the land masses are now really sort of wrapping up. And so this, you can think of this also as a topographic map too. So this high pressure system now is much higher than those cooler colors. Flow is still around the high pressure system clockwise, but it's moving closer towards us. And so that means the gradient is getting a little less tight. So the jet stream is now much further north. And then as we move into July, there's kind of this big shift of the high pressure system. It's that lagged response of all that surface heating from the high sun now is overhead, hopefully north of us. And that's where we get into this idea of, we call it the four corners high pressure system. So is this mid-level high pressure system with the flow around it clockwise again, is it now not overhead to the north of us or off to the east of us, where the flow now is taking wind out of the east, southeast, and south, which is on the south side of this high pressure system is tropical air. And so if we can do that, we're going to pull tropical air into the region. We already have high sun, lots of heating. All you need to do is throw that fuel in there, and then we'll start to generate thunderstorm activity. So this is that seasonal wind shift. It's not like the East Asian monsoon where you've got 180-degree shift in wind. It's real subtle. It's like from southwest to south to southeast because of this shift in high pressure. Okay, so there's a lot. This is like too much information. I just want to draw your attention to some subtle sort of geographic features that occur with the progression of the monsoon. So this far left panel is that same set of maps I talked about, but this is broken down by June 15th, July 15th, August, September, and October. And so it's that you can still see that it's the same mid-level high pressure system, but you can watch it from June 15th to July 15th on average is a pretty quick progression to the north. By August 15th, it's already weakened. By September 15th, it's already moving back to the south. So this hopefully gives you a sense of, it's pretty quick. It happens fast at the beginning of the monsoon, and then the retreat is going to happen pretty quickly through August. So we have a monsoon season that we call June 15th to September 30th, which is the official definition by the National Weather Service. That just gives us some good guardrails to where we should look for this change in wind and then the moisture coming in. But it's usually in a much tighter area temporally within the whole monsoon season. And then what happens with this high pressure system, mid-level high pressure systems, you can see here that there's a march of precipitation up the mountains in Mexico, and it starts to reach up into the southwest, and then it quickly retreats in September. This is PWAT is precipitable water, so it's the measurement of water in the atmosphere. Those green colors are that deep tropical moisture. You can see from June 15th to July 15th, it starts to flow up the Gulf of California and fill in the coastal plain and into the low deserts, the coastal plain of Mexico and the low deserts of Arizona. And it's also kind of filling in from the Gulf of Mexico here. And then by August 15th, it's usually parked here, which we can start to use for those thunderstorms. September 15th, it's already getting washed back out because we're back in the westerlies. October 15th, it's over. I mean, at that point, if we're getting any rain, it's usually a tropical storm, which isn't really monsoonal, or it's an early winter type storm at that point. And this final panel here is the instability in the atmosphere. So it really just follows with all of these things. These deep purple colors show that instability, which is related to the water in the atmosphere. Okay, this is kind of another way to talk about it. And I love reading Bob Maddox's blog, and he's a retired researcher from NOAA and has written a lot of papers on the monsoon, but he talks about this idea of a maritime tropical air mass, which I think is really a great way of thinking about it. But it's this kind of continuous air mass to the south of us that is not over the desert until this shift in the subtropical high pressure system, and it gets dragged up in here. So I made this map just looking at, we use this kind of threshold in the atmosphere here. June 15th, we're still in dry air here, but you can see here the progression from July 1st to July 15th to August 1st is that movement of this moist air mass up in the southwest. You can even see how it really does kind of truncate along the Colorado River Valley on average. Sometimes it will be able to flow into Southern California like Ben is seeing right now, but oftentimes that'll get just shunted back into being really concentrated over the southwest, and Mexico is completely in it through the season. Okay, just another way of sort of looking at this is the progression here is in early June. That tropical convection is in for southern Mexico. And as you go into June and into July, it starts to move up the spine of the mountains in Mexico, and then filling in along the the western side of the mountains in Mexico, and then moving into Arizona, hopefully on time in July. No problem this year for sure. Also, just to kind of point out too, the core of the monsoon is really in Mexico. This is the periphery. We are on the periphery. It's so important to us, but we also have to recognize that some of our variability, a lot of our variability is associated with us not being sort of the core domain of the monsoon. Okay, this is just another cartoon. I think it says the same thing. Position of the four corners high. We also have a low-level thermal low because it's so hot in Yuma, which also helps to draw in moisture along the Gulf of California, which we would call a Gulf surge event if we can get the pressure differential right, and then puts us into filling in the moisture at low levels and at upper levels, gives us the best chance to having widespread thunderstorm activity. Again, last week, no problem. That was a classic event, having all those things converge. So there's often questions too. This was in the literature for quite a while, and I think has really been nailed down nicely with both studies of 10, 20 years ago, but then more recently using different analysis techniques. This is a cool paper from a couple years ago that if you look at these little black dots, these are stations where they're collecting rainfall data, and they did some analysis where they ran a model backwards to try to figure out on a rain day, where did the moisture come to bring the rainfall on that particular day back in time. And so at these different locations, was a back trajectory model is what it was called. It was the count of where the moisture originated from at these stations. So like in Cedar City, Utah, right up the Gulf of California, right up the Colorado River, is where most of those rain events came from. Grand Junction is kind of a mess. You can get some from the Gulf of Mexico, some from the Gulf of California, and the other side of Colorado here in Eastonville, Colorado, it's almost all from the Gulf of Mexico. As we get down here into central Arizona, Gulf of California, and then Red Rock, New Mexico, right on the border, you're getting both. And so you can see as you move across the region, the importance of Gulf of California moisture becomes more important to Arizona, especially go west. As you get into kind of the middle of between Arizona and New Mexico, you can get both. You get into Colorado or New Mexico, Gulf of Mexico becomes more important because we have this spine of mountains in between, which really separates the air mass from each other. Okay, so just a couple final maps here just to look at the climatology of monsoon precipitation. And so this is across the whole Southwest. This is the climatological average, 1981 through 2010 normals period. We'll move this forward and update it, but largely I think it tells you a good spatial picture here of the total June, July, August, September precipitation. And so New Mexico ends up getting a lot of precipitation in June on the Great Plains side of it. And then it really shifts over as they dry out. July comes online. We start to see more precipitation in the higher elevations across the state. And then it gradually sort of fills in as we get into August. And that's what this set of maps right here shows, is the progression here. June, again, Great Plains, eastern New Mexico. You can see the highest months of precipitation are on the mountaintops because that's the best chance you have is driving some of that convection is going to be over the mountains, probably won't move into the valleys. The moisture isn't deep enough. By July, more moisture means more opportunity to move to lower elevations. And then by August, we're usually in the soup and you have the best chance of sort of spreading the moisture around. And so that's usually peak monsoon precipitation is in August. And you see how quickly it drops off here in September. It's not quite as dry as June, but it's definitely drier than August. There's a real stark shift in precipitation from August to September. Okay, and then this is a map that shows the percent of annual average precipitation, zoomed in on Arizona here. So the percent of annual average precipitation, every one of these pixels, how much is contributed of the annual to the annual total by June, July, August, September, so the summertime. So I had to really fix this color ramp to be 50 would make more sense, but this kind of pivot point is 40, goes as high as 70, as low as 10. You can see right here, this break point between low deserts here and Southeast Arizona, where there is less than half of the annual total is occurring in the monsoon, and more than half is occurring in the monsoon across Southeast Arizona. And as you go further south into Mexico, becomes even higher. And as you go further north, it gets to be even lower. You see California here is that the amount of monsoon precipitation is really quite low relative to the annual total. And then finally, and I'll turn it over to Ben, is just some context on some longer term precip variability. This is a part of a study that Ben and I are working on, looking at long-term monsoon variability. And I've just clipped out this domain here of Western New Mexico and Arizona, and then looked at the average precipitation for July, August, September for every year back to 1900 and going forward, and just put it into context what 2020 was like. So 2020, in this over 120-year record, this was last summer, was the driest by quite large measures. You know, we had a couple years that were a bit higher than we saw in 2020. So it'll be really interesting to put this bar for this year back in, and we're already above average probably at this point. I'd have to think about that. If we're Tucson, we're already above the whole seasonal average. So I expect the region as a whole will probably pop back up. So the point of this is that there isn't any really detectable long-term trend in monsoon precipitation. You can carve it up a lot of different ways, and we've been looking hard to try to see if there's any trend, and there really isn't. There's a lot of variability, and we do get these sort of swings where you can go from a dry to wet summer. Seems to be kind of baked into the natural variability of the whole system. Okay, so I'll leave it at that, and then I'm happy to field some questions once Ben's done as well.
Awesome. Thank you so much, Mike. I have to say, I've always been a little intimidated by weather science, but I feel like the maps have really just opened my mind to like how it all works.
Oh, good. I'm so glad. I hope it wasn't too fast or too complicated, but we can definitely hash some stuff out in Q&A.
Yeah, and it seems like it's a huge topic with just a lot to discuss, but yeah, thank you.
Yeah, yep.
So Ben, I'll pass it over to you. We'd really love to know more about, climate assessment for the Southwest and the research that you guys are doing.
Yeah. So yeah, I'm just going to give a quick overview. I pulled together a few examples of how we track the monsoon, and also just a couple of case study examples of a few research projects we do with monsoon data, just to kind of give a taste of the type of things that we do with CLIMAS. So just a quick background. CLIMAS has actually been around since 1998. It's a NOAA-funded program. It's called the Regional Integrated Sciences and Assessments Program. And there's actually a bunch of different CLIMASes around the world, the country. They're not all called CLIMAS. They each have their own little name, but we're the Arizona, New Mexico Regional Integrated Science and Assessment Program. And so, that's a group of people that's made up of a bunch of different disciplines. We have social scientists, physical scientists, natural scientists. And the real thing is we work with partners around the Southwest, really to think about regional climate challenges and how the research we do and the data that's out there can help inform some of those decisions. And really one of the frequent topics is drought, water supply, and precipitation, but of course the monsoon. And so what I wanted to talk about today was just a little bit about how we keep track of the monsoon, where we put some of this information, where we curate some data from other sources, we put together some of our own stuff, where that's located if you wanted to follow up with a little bit more detail, and then just a couple of quick examples of how we've been using some of these data to think about monsoon questions. So this is actually a version of the map that Mike just showed. This is 2021 so far. And so this is a map that just shows kind of how much rain has fallen around the region, and just gives you a sense of where we've seen some rain, where we haven't seen some rain. But what it doesn't contextualize is kind of what you might expect. And so the next map is another one that Mike uses that he's put together for us. Thanks, Mike. That shows the percent of average. And this is the percent of average monsoon precipitation starting June 15th through, I guess I did through yesterday. So you can see there's actually, when I mentioned before that it's been a pretty egalitarian monsoon, we have quite a few areas in this kind of core monsoon region that are well above their to-date average. So, Phoenix, Tucson, Safford, Flagstaff, El Paso for sure are all doing really well in terms of those monsoon totals. We also see some areas that are a little bit below or behind the curve, but there's still time left in the monsoon. And one of the points we'll be driving here is the monsoon every year ends up being highly variable. So it's not unexpected to see some areas that are well above average, some areas that are well behind average. But if we pulled up the map from 2020, you would have seen a map where almost the entire region was below average. So really, again, this big difference from 2021 versus 2020. Another way that we sometimes take a quick look at kind of how things are doing is just at those regional stations around the region. So this is something that we pull together every month, just to kind of see how some of the major metro areas are doing compared to their average and their recent years. And so you'll see the green bar is the normal seasonal monsoon total. So that's that June 15th through September 30th total. The orange bar is the amount to date as of, I guess, yesterday. And then the blue bar is the 2020 total. And so, what we see is kind of a quick reference here is, most of the region is doing quite a bit better than 2020. And a few of the stations are actually even ahead of their, what you'd consider their seasonal average total. So Flagstaff and Tucson are both just charging ahead, or I guess Tucson and El Paso are just charging ahead. Flagstaff is close. So again, this just gives us kind of a quick reference point of, how the stations are doing, what we might expect. But what it doesn't say is how the rain fell. And that's really important for monsoon. Was it gradual? Was it all at once? Did we get one big record day, or did it rain a whole bunch of days across the season? And so another way that we take a look at monsoon precipitation is to take a look at the daily amount of rain that fell, as well as the cumulative total. And the important part for this plot, I made the temperature a little bit less prominent, so we could focus on the precipitation. But the light blue line is kind of the average amount for June 1 or June 15th through yesterday. And that dark blue line is what actually fell. And so what we see is for Flagstaff, Phoenix, and Tucson, all of them were, running pretty close to normal around that line, had a few days here, a few days there. And then around mid-July and into late July, we really see this rapid ramp up in precipitation. So we see that it wasn't just Tucson, it wasn't just Flagstaff, it was all around the region, especially in Arizona, was seeing this big spike in precipitation over the last week. If we look to our friends to the east, for Albuquerque and El Paso, Albuquerque is actually pretty close to normal through the to-date total. They had kind of a relatively early start with a few days here and there, and then their cumulative total is running pretty close to their seasonal average. And then with El Paso, we see what it looks like when you have a really strong early start. Even in late June, they had a really big event that came through and a number of days of rain. And then they picked up a little bit with these most recent storms. And so they're running well above their seasonal average as well. But a lot of that is because of that early kind of a quick start to the monsoon. And so, what this gets us thinking about is not just where we're at in terms of, how much percent of average at the end of the season, but how did that rain fell and like, what did that feel like living there? And, some of these days where you have these rain day after rain day after rain day, it feels a lot different than if there's just one record day. And so for more information, I'm not going to get into all the details on this, but the CLIMAS website has quite a bit. We do a monthly climate outlook that will summarize a lot of what's going on with regional weather and climate. During the monsoon, we always have a monsoon tracker that points to a lot of these maps and data that just to kind of keep track of how things are going. Mike is actually also on this podcast. I help produce it, but Mike and Zach are kind of, I've heard it called Click and Clack for Weather. I don't know if anybody remembers the Car Talk podcast, but just kind of a commentary on the regional Southwest climate. We do that usually about every month or so, but during the monsoon, we do it a little bit more often because there's actually just so much to talk about. And then I put a couple other websites we have on the CLIMAS page and then Mike's Climate Science Applications Program, both of which are, if you really want to dive into the details of, how we track the monsoon or what are some of the data and sources we use to kind of think more about that, those are both places you could go. Now, just to take a quick look at a case study example, Mike mentioned we're already record for the Tucson airport, and that's true. As of July 27th, 7.08 inches, I think, for July, which ranks as the #1 July. So we're already ahead of the record, even no matter how much rain fell today or for the rest of the month. But if we look at the seasonal total, that 2021 total is still only not even quite top 30. So we're getting close to top 30, but there's still a long way to go for that record rainfall type level. So this just shows, you might have a good month, but there's still quite a bit of variability month over month. And so what this really got us thinking about is like, how do we track monsoon variability? And so Mike mentioned that the June 15th to September 30th is the season. So a lot can happen in a single day, much less a whole season. And so what we really kind of grapple with is this challenge that monsoon storms can be incredibly variable over short distances, which make them really difficult to track. And what's running in the background is a storm system from July 2nd of this year, where it really started to build. And I was watching this, and about right now, it's like, man, it's really coming down in the foothills there. And then at about, I think this moment, just the sky opens up and just dumps water on the foothills there. And so you can see, from where this picture was taken, it probably wasn't raining, but where that storm came down was actually an incredible amount of rain. And so what this really raises is the challenge of any given monsoon storm can rain a whole bunch. And if you live in the region, you've experienced this. Your neighbors got a bunch of rain and you didn't get any, or you got a bunch of rain and your neighbors didn't get any. And Mike and Zach and I always joke, like, did it rain at my house? That's kind of how we decide whether it was a good monsoon storm or not. But it really got us thinking about how we could track this a little bit better. And so one way we've been doing it is pulling in some of the flood control district stations. And so what I have here is the July total on the left map for 2017 and the July total to date for 2021 on the right map. And really kind of the big takeaway here is the distribution of values. And this is what I was saying as far as it being more egalitarian. What we're seeing with 2021 is just widespread around the region, especially in the Tucson metro, but also in Southern Arizona. So many stations are doing well with their seasonal total. And the airport set a record, but sometimes the airport can set a record, but it can be the wettest or one of the wettest stations in the region. In this case, for 2021, the airport's right in the middle. There's a bunch of stations that are wetter and there are some stations that are drier. So when we're looking at those airport totals, it gives us one metric, but when we start to look around the region, it really helps us fill in those gaps and better understand what's going on with monsoon variability. Another way to fill in the map, who doesn't want more data, right? So the rain log network, which Mike actually helps run, this is a 5-day total from July 21 to 25th, and it really shows just how much rain fell in the region this year. So, and it wasn't just, down by the airport, it wasn't just the foothills, really the whole region saw pretty substantial rain. And, we see higher totals in some places and lower totals in others, but this just helps us illustrate like when the monsoon is pretty widespread and when it's a little bit more variable. A quick example of how we can use these data. This is a good example. On the left there is July 23rd from 2020. You can see there was a big storm that passed through. It hit Midtown and the foothills. And there were a bunch of stations that recorded precip of up to 3 or even 4 inches of rain. Well, the airport that day only got 0.15 inches. So if you're looking to the airport to say how much rain fell on July 23rd, it's a pretty low number. But if you lived in Midtown, you'd say, well, it rained a whole bunch. And so this is just a way for us to get better data about some of that high level variability. And then the upper right example is a really light event. The airport recorded 0 precip, and there was just a few stations there on the west side of Tucson, but we wouldn't have known about that if it weren't for the rain log network filling that in. And so a couple examples of what we're doing with this. One is just a better understanding of monsoon variability. We're using the station data to track some of this variability and just thinking through what are some of the applications for flood risk or drought monitoring or other ways to think about how that might be useful. And then I also wanted to flag, we also have a collaboration with the National Phenology Network, which is using some of the station data to think about how they identify hotspots for monitoring and to validate and improve their bufflegrass green-up forecast. So an invasive species that lots of you are probably familiar with, but what's the role and how can these precipitation data help inform some of the monitoring efforts there? And so really these projects, the point I want to make here as I'm wrapping up is that these projects wouldn't be possible without the community observers and the volunteers. And so I just put in the slide here a bunch of different ways if you want to get involved to help submit your data. Some of you, I'm guessing, are already rain loggers or people in CocoRa's network, but this is a way that you can get involved if you want with the Rain Log Network, the CocoRa's network, the National Weather Service Citizen Weather Observer Program, or the National Phenology Network. And so with that, I will leave it to questions for Mike or possibly myself.
Awesome, Ben. Thank you so much. That's really fascinating, those maps, and wonderful that it's so available for everybody to go and take a look at. If you didn't notice, there are some links that Mike has dropped in the chat for you to learn more about the Precip Viewer and the monsoon maps, and then I put a link in for the rain log. So please go check those out. And if you have any questions, now is a great time to ask them. I do have some questions already that I will just want to add a spotlight for Mike. There we go. Okay, so yeah, we'll move to questions now. The first question was one that was submitted when people were registering. Paula wants to know how the monsoon is responding to increases in climate change. Can you guys speak at all to that?
Yeah, I'll try. I've gotten this question from the media quite a bit this particular week, and it's not real clear. And we've been kind of driving at looking at trends in the data, and we don't really see any trends in precipitation or the timing of the monsoon, the cessation of the monsoon. And it's not just us. There are numerous papers out there that have tried to document variability. There's a couple of papers that have hinted at increasing intensity of precipitation during the summer season. That makes perfect sense. That's probably the most straightforward pathway for climate change to impact the monsoon, which would be increasing amounts of moisture in the atmosphere. We've observed that. And so that would lead to the potential for more intensity within particular rainstorms. And there was a paper by some colleagues from USDA down at Walnut Gulch, which is down by you, Anna, at the Walnut Gulch Research Watershed that didn't find trends in some of the typical metrics, like maybe seasonal totals, annual totals, or even using some of the daily. But then they did find, because they have a really high resolution network at hourly, they did see an increase in some of the sub-daily rainfall intensities. And that to me makes sense. But in some of the other mechanisms that the way that climate change could impact the monsoon, they're not super clear, but it could be that the subtropical ridge of high pressure system actually gets bigger. This is some work from our colleague Chris Castro at University of Arizona. So it becomes more expansive, and it might push some of these what we call inverted troughs of low pressure system more into Mexico, because it becomes this quote unquote heat dome becomes bigger, and then it shoves some of that activity through Mexico and leaves us with less opportunity. But we've seen the converse this particular summer, which is the ridge of high pressure has been so strong and pushed so far north that it's left us in this really nice deep easterly flow. I mean, that doesn't mean that that's not a long-term trend. This could be, this year could stand out in converse to that trend, and that trend may pick up over time. So that was a long rambling way to say, we don't really know. The research is has not sort of locked down anything. There's a couple of review papers that say this very thing. But I think that atmospheric moisture is probably the best place to look. I looked at some dew point data today for Tucson, and I didn't actually see any trends in it as well. Doesn't mean that couldn't be an issue in the future. So that's probably a lot of waffling and dithering, but I'm used to doing that.
I would just say, like, just because we don't see a strong signal in the data doesn't mean there isn't a climate change signal.
Yeah,
it's just
Mike,
right. As Mike mentioned in his presentation, we're really at the periphery of that monsoon area. So we already see a lot of variability. Because of that variability, even if there was a strong signal, there's just a lot of messy noise with that monsoon variability that's going to make it harder to see a strong signal. So I think we've been looking to see if there's any climate change analyses for that core monsoon region as well, just to see if that shifts, because that will give us a better sense of how it might affect us at that periphery. So
that's nice cleanup, Ben. I appreciate that. Climate change is part of every weather event right now. It's just how much is it actually contributing? It's probably quite small right now down here. In other parts of the world becomes much more dominant, but down here, just as Ben said, we have so much interaction variability and noise in the system. There already is baked in variability, so it's hard to see that signal really come out in front of everything else.
Okay, kind of tagging off that, I just received a question. Is there a connection between the record high temperatures in Washington, Oregon, southwestern Canada, and then our temperatures?
Yes. Yeah. Do you want me to take it, Ben?
Yes.
Okay. So, yes. So so what we were talking about earlier, when I showed you those maps of that high pressure system, that H kind of moving north, that's a natural progression of the subtropical ridge as it moves up into the western US. And so if you're underneath that H, you're going to have the highest temperatures. And that can be stronger or weaker in any given year. And it was very strong this year. So our heat wave in June, which broke some records, actually was part of that subtropical ridge, which then continued to progress north and had a real strong kink in the jet stream that you can trace back to actually some typhoon activity that occurred in the far western Pacific that caused these real strong waves in the jet stream. And so that kink in sort of pushed that ridge up over the Pacific Northwest and up into Canada and caused that high pressure system to settle there and bake the area and bring, crazy record-breaking temperatures. At the same time, we're south of that. It put us into this real nice easterly flow, which is on the south side of the high pressure system, which set up the early onset of moisture into the region. So it was all completely connected. And unfortunately, we benefited from all of that record heat because it ushered in the monsoon a bit earlier than usual.
All right. I had a question on Twitter probably a week ago when we started to announce this coffee break about kind of forecasting for monsoons. And they mentioned that before the monsoon season actually hit, there weren't great forecasts for rain. You were kind of worried about, 2020 was a really poor rain year and it seemed like it might be continuing. And then now we've had like record-breaking rains in certain areas. And so they were wondering kind of like, how does that forecasting happen? And like, how does that message just change so drastically?
Welcome to our world. So seasonal forecasts. So weather forecasts are, done with these high resolution dynamic models, and they're usually quite good and skillful for about 3 days. And then you get out to this sort of 4 to 10 day period, and there's a lot more uncertainty. And out past 10 days, these dynamical forecasts really fall off. And so predicting like rainfall amounts 10 days out are usually very uncertain. So we work in the area of communicating seasonal forecasts, which are past 10 days. So they're weeks out, if not 13 months out. And those are probabilistic forecasts. So they're not deterministic in the sense we're not telling anybody whether or not how much it's going to rain in a particular location that far out. We don't do the forecasting. We help sort of communicate the forecasts that are in the US done by the Climate Prediction Center, NOAA Climate Prediction Center. They're probabilistic, and all they will be able to tell you is there a better chance of being in the wettest third near average or the driest third of historical values for a particular period. And so when you look at the wintertime down here, the most important forecasting tool that forecasters look at is the state of the El Nino Southern Oscillation. And so in the fall, if we're in a La Nina event is expected to persist into the winter, you're going to get a forecast for drier than average conditions across the Southwest. And those are actually usually pretty good. And we saw that last winter. If it's an El Nino, that gives us an elevated chance of seeing wetter than average conditions in the winter. Sometimes it doesn't work out. Once you get into the summer, though, we don't really have any strong connection back to something like El Nino, the Southern Oscillation, that would give us the slow moving trajectory that might give us an indication of whether or not the summer will be wet or dry. And that leaves us with looking at dynamical models, which can't really see all the real small scale, subtle things like what we saw last week, months out in advance. They were really, we saw them at about 7 days on this forecast. The forecast was quite good, but the actual track of the feature that caused all the rain was wrong. It still worked out fine, but it went a slightly different path, and it ended up bringing more rain to some locations. So the seasonal outlook is, at this point anyways in time, is never very certain. And you have to get right up on top of the monsoon season in late June to just try to peek into these weather forecast models to even see what's going on. And right now we're trying to understand what August might look like. And so two of the biggest models that are used in the world, the US version, the climate forecast system, and then the European version, the ECMWF, have completely conflicting signals right now. One says wet August, one says dry August. So you average them together, you get average conditions, but clearly it could be anything in between.
Okay. Ben, for people who want to get involved in the rain log and kind of help with this research from home, is that just something that's located in kind of the Tucson area, or can anybody across Arizona, New Mexico help?
I mean, technically RainLog is worldwide. I mean, Mike helps run it, so you could speak to it. CocoRa's, I think you have to go through a specific training and use a standardized gauge. RainLog, anybody who has anything that will record rain is able to, join the website and submit their data to the website. And if you're one of the people who's been logging precipitation forever, I believe RainLog also has the function where you can backfill in. So if you have 10 years of rain data, you could actually put that in. That's correct, right, Mike? Okay, I didn't want to promise.
Yeah, no, that's great, Ben. And so RainLog was homegrown. We set it up here in Arizona, and it's a pretty flexible system, and it allows you to use your own kind of gauge and put in historical data. CocoRa's is a more official network, requires standardized gauge, some training. That data goes into official NOAA data sets. So they're really complementary. It's kind of how, what's your level of commitment? You want something a little bit more informal, RainLog. You want something a little bit more formal, a little higher bar of participation. CocoRa's is great. We use both the data, and they're really complementary. Ben also mentioned the Citizen Weather Observer Program. So if you have a home weather station that's already reporting to the internet automatically, you can actually pipe that data into, it's called CWOP, Citizen Weather Observer Program, and it will end up in a NOAA data set that we actually are using as well. So, there's just kind of ample opportunity on the kind of weather climate side of contributing data, and just kind of figure out what fits best for you.
Yeah, and the fun thing about that is as you're piping in your own data, then you can look all around and see what else is happening around you. So it's, I think in, the pre-internet days, you had your rain gauge and you just kind of kept track of what was going on. But then when you start to see all of what's going around, in your city or in your county or in your state, it's just really kind of fun to track. So. Absolutely.
And I just saw in the chat, Gail mentioned Skywarn. And so that's another great program. The National Weather Service, your local National Weather Service office will offer spotter training, and that will also get you into the CocoRa's network as well, but it'll give you training on how to report extreme weather events and help them verify some of their weather warnings.
Awesome, thank you. Prudence asks, what role do social researchers have in your work at CLIMAS?
Yeah, it's a great question. I mean, as an anthropologist, I appreciate that there is a role. It's a growing thing in the role of social sciences in atmospheric research. I mean, Mike and I have a recent project where it's an assessment of how to figure out what are the risks that someone perceives as part of their management decision, and how might they integrate climate data into what they do. And so it's interviews, it's focus groups, it's sitting down and having a conversation with, what's the timing. We've shown you dozens of different data sources and timing, and that can be a little overwhelming to somebody who just wants to figure out how it's relevant to them. And so sometimes the social research element is sitting down and figuring out, well, okay, so here's a dozen things, but what are the 2 things that are actually relevant to the decision you want to make, or the question you have, or what's your priority for a question you don't see us asking? And so that'll be another thing in this collaborative side, where some of our partners actually help define some of the research questions that we then pursue in subsequent proposals. And so some people call it translational research, but I think it's more of a collaborative process where there's lots of different types of expertise. And I think CLIMAS is one of the examples of the type of programs that have, that range from social to natural to, physical sciences, and the conversation between all of those.
Yeah, just to tag on too, I've been blessed to work with this team of social scientists, including Ben and at CLIMAS. And I'm trained also as a geographer, so I have an appreciation for social science, but you can't really do good applied work without that social science support, because we wouldn't know what the application would look like without really good engaged processes.
All right. I think we have time for one more question, and I feel like it's probably a good thing to end this on. So for people who are really interested in monsoon science, and just learning more about how it all works, because I know we got kind of a snapshot of everything today, but I mean, I found it personally very interesting. So for people who would want to learn more about monsoon science and kind of everything that you guys are doing, what would you recommend as far as resources go, outside of like maybe the CLIMAS website?
So I'm gonna put in chat. I wrote up an extension bulletin. This is like 15 years old now, but it's kind of a primer on the monsoon, and I need to update it, but I think largely it still kind of hangs together. The Tucson Weather Service has a monsoon tracking page, which has a lot of great resources in it too, and we should pop that into chat as well.
Yeah, I was going to say if you want to get into the details, there's like as an example, Mike mentioned that seasonal progression of the pressure. I think Bob Maddox actually wrote it, but on the National Weather Service Tucson page, there's a really nice detailed explanation of each one of those phases. Mike, are you pulling it up, or I can pull it up? But it helps explain some of those, how the pressure changes, and kind of what role that plays and the type of events we might expect to see during each one of those phases. And it's not, a rigid system. It's not like this happens from June 15th to June 30th, and then on July 1 it changes. But you get a sense of, okay, now we're kind of in this phase, and this is the type of thing we might expect to see. And like, okay, now we're kind of in that end of season transition phase, and we might not be seeing as much regular rain, but maybe a tropical storm might roll in. And so it just gives a sense of, at the big picture, kind of what you might expect. So yeah, that thing Mike just dropped in is really helpful for that.
Totally agree.
Awesome. All right, well, we are at 10:30, so we'll go ahead and end the presentation. But thank you both so much, Ben and Mike, for joining us today. Lots of really fascinating information, lots of great ways for people to get involved from home. We love that community science opportunity, being an organization that's really driven by community science efforts. So yeah, thank you so much for sharing your knowledge. And I hope everybody on this chat gets more rain and just really gets to continue to enjoy the season. And hopefully August is a really nice wet month for us.
Absolutely.
Yes.
Thanks for having us.
Yeah, this was great. Thank you so much.
Yeah, our pleasure. All right. Thank you, everybody. I hope you have an awesome day. And if you need the recording, it'll be up on the website later today. So, bye.